One of the most common difficulties I hear about wanting to utilize AI within data infrastructure is that my data has too many problems. It is not clean enough. It is not arranged in a way I would like it to be. It is not relational. There's a lot of nuances, and really data quality and data infrastructure are serious obstacles for everyone across the data profession. I know every single company I've worked in has had different issues and different things to account for. And so there's so much internal context. So it raises the question, how can we actually utilize AI effectively when we have all this knowledge in our head that otherwise AI wouldn't know about? And that's where this comes in, the product requirements prompt for data object. We can actually utilize AI to help us improve our data quality, finalize our data objects to get us to a more completed, easy to use infrastructure. And I'm going to show you exactly how to do that in this video with the prompt templates I have, the custom command templates I have for Claude Code. And this will show you that your data does not have to be in a final place for you to utilize AI. So what are we going to learn exactly, and what is the value of what will we be learning? Well, the first thing we'll be talking about is what the product requirements prompt is and how I've adapted this specific prompting strategy and context building strategy for data objects. Here, I give a lot of credit to the YouTubers Cole Medin and Rasmus Whiting, who paved the way for actually developing this framework more for the engineering side of things as opposed to the data side of things. So I've adapted it a little bit for my specific and our specific use cases. And then secondly, we're going to talk about how to create specifically SQL-based data objects using the generate-data-object-prp and the prp-data-object-execute custom commands, which I have here pulled up alongside underneath the commands folder in the .claude file. And then the value of this, like I said, right, you can use AI to actually accelerate the improvement of your data infrastructure, and the data quality issues are no longer impediments, right, but are opportunities for you to employ this framework and utilize what we have learned from this video to adapt and create these templates and execute these commands that will ultimately end in better data objects and more usable data objects, not just for AI, but for you if you're issuing queries on a day-to-day basis. And then lastly, you can adapt this PRP framework for other projects you want to complete. So this PRP framework is not just specific to building or editing data objects. Well, this one in this video is, but the concept of it, right, can be applied to many other things. So if you have DBT objects and you want to approach this in a different way and you're using DBT to organize your data warehouse, that's something you can adapt this framework for. You can utilize it for completing tickets, like in the ticket workflow video that I showed you guys previously on my channel for Jira and Claude Code, as well as the Claude Code overview video. There's a lot of value within these prompting strategies and these context building strategies to have Claude Code and, again, whatever generative AI system that you'll be using in the command line to be successful when actually improving your data infrastructure. With that, let's actually get into the content of talking about product requirement prompts, or PRPs. What is it? Well, what I found with a lot of different AI systems and tools is that at its core, it is a document, it is a piece of text, it is a prompt that gives the AI agent, AI coding system, a specific set of instructions, guidelines for how it needs to implement or alter a data object. And the goal of this PRP template is that you need minimal iteration. So I'm not going to say that you're going to get it single pass every single time, but you're going to limit the amount of times that you have to instruct and provide feedback to AI by following this framework. And again, I mentioned this at the start of the video that I borrowed this framework from Cole and Rasmus, but I've adapted it to data. I've linked their videos here. highly recommend them if you want to look at the origins for the context engineering framework here that really come from software development, AI, agent coding development. But moving on specifically to our data PRP, when you're developing a data object, right, oftentimes it takes a lot of different iterations. I know for me that I have to think through the grain, think through the data sources. If I'm building something very complex, there's often edge cases that I'm discovering, and that cause me to rethink how I'm approaching the data object. And a lot of people have different styles for how they create different objects. So you can have different standards across your team, across individuals. And what PRPs do is it allows you to solve this by front loading the research, providing a specification for how you actually need to create and alter the data objects. And ideally, you get the one pass implementation success. Again, not promising one pass, but that is the goal here, right? To make it as comprehensive and clean as possible so you can improve your data infrastructure in as efficient way as possible. And so this breaks down into a 4-phase workflow where what I'll show shortly here is there's an initial markdown file where you fill out the requirements for your data object that you want to create or edit. There is the generation of the PRP, which Claude Code actually does itself. Again, we're using AI to build out instructions for AI to execute on to be the most efficient possible. And then phase 3 is it actually creates the development object and does the QC of that object. So if you have a development schema in your database, ideally you're using that with production data so you get an actual look of what is being created. And then if you need to provide feedback, then you can iterate within this phase. However, if you don't, then you move to the 4th phase, which I always leave to the humans in the loop, which is ultimately production object deployment and saying, hey, this is a source of truth for our organization after you've been able to review all the previous steps. Now, I'm going to cover each phase of this workflow, and then we'll go through a couple of examples to show you exactly how it works. So you can deploy the same custom commands and templates I'm using within your own workflow or adapt them as needed. So the first phase here is defining requirements, and this is using an initial markdown file. And what this is, it's capturing the requirements and helping you think through what you really need out of this data object before the research begins. So this does require some work on your part. I'm not going to say that this is without work, as you need to understand your data sources, at least have an idea of what you want to create and have an idea of where you need to pull that data from and how it can be assembled. But a lot of this, you can have AI conduct this research for you, and this can be sorted out in the second phase of actually generating the PRP if you're not entirely sure about all your requirements, all your data sources, and you need AI to help you with that specific research. Now, for this initial description of the requirements that you need for your data object, you can find the template I have underneath this file path that I will put in a link below in the description. And you can see that generally this is a fairly straightforward template that has different variables or options that you can choose from at each point. So you can create a new object or alter an existing one if there's something that you need to alter in a big way. Or if you're only creating one table or multiple related objects, maybe that have defined relationships between them. Maybe you're creating some form of star schema with dimensions and different measure tables, different fact tables that you need to create. And then you have the object definitions. And so you can have your primary object name, what you want it to be, view table, dynamic table, which I think is specific to Snowflake since I utilize Snowflake the most. and then the schema name for what schema you want it to be created in. And you can also specify the database as well. And all of this is very customizable for how you want to build these objects. And then you can say, all right, I have these other objects in the case that you have multiple related objects. If you don't, you can just delete this section. Same for this. If you have an alter existing, you can just delete the section. And oftentimes with filling out this template again, and I'll show you this later, you can have AI help you fill it out for you, especially if you're doing an alter existing one, right? Where if you're altering a view that already has some defined language, defined SQL behind it, you can just have AI do that research for you and then describe what you need exactly changed to. And there's also some backward compatibility, expected changes. It gives you a lot of details in here that you can input into it so you can describe accurately what you want to come out of this data object. And then you get into the data grain and aggregation, right? Which I know this is something that I've encountered in my years within data, where oftentimes you're pulling data that is different grain and combining it with something at either a higher or lower grain, and you have to perform some form of aggregation. And so this gives you an area where you're able to define that as far as how many rows you expect, what are your primary keys, right? And your time period, key dimensions, different things that you can further describe there. And then you have an area for business context where you can help illuminate the AI or Claude code for why this object is needed so it can actually think through different scenarios that it might encounter in its research as it prepares this product requirements prompt, as well as the key metrics, KPIs that you'll be using it for. And then a section on data sources where you can talk about, all right, I know I need this data from this specific table, this specific view or dynamic table, and then this is a join key. I know for me, there are oftentimes very confusing join keys between tables. And so this is an area where you can really help AI out or say, hey, this ID field does not match to this ID field in this table. It actually matches to something else that is randomly named, something that it probably shouldn't be. And so you can help define those relationships here and begin to establish that knowledge for AI to understand how it's going to work. And then you have your data quality considerations, if there's any messy data that you know of, duplicates, and as well as data differences, column values. And then you get your final requirements, performance, refreshing, data retention, and then ultimately whether or not you want a ticket created. And again, this is created for Jira specifically. If you want to create a new ticket for that, that's an option just to make sure you have this work tracked so you can track it within your tickets workflow that you have here that I described in my previous Jira and Claude Code video, as well as any other additional context that might be helpful too. And so this takes you through the initial markdown file, which it is a bit of work. I'm not going to lie, as I said before, but it really helps you not only describe it to AI, but also helps you as an individual data developer, right? And a person who is looking to create objects or alter objects, think through what it is you really want. Moving on to these next phases, I'm going to spend a little less time on these because these are more AI relevant phases, if you will, or AI involved phases, where the first phase of generating the initial template that I showed you all involves more research and more effort from you, the human involved in this process. But that said, we have this generate-prp custom command, which I have pulled up here, where it takes in the argument from your initial markdown file that you defined, and then it basically goes through a research process looking at the different aspects that you want to implement and ensuring that it is possible to do that, and constructing this image for all the different data sources, the logic, how it can actually construct this within the constraints and the requirements that you've provided it for the specific business reason, and making sure that it is meeting that case. I see some things in here that are a little bit more specific to my use case, like Snowflake. So I'm going to eliminate these out of it before running my final commands, just to make sure we're working with a universal template here as well that you all can download for whatever data warehouse system that you're working off of. And going back to phase 3 now, once phase 2 execute, what it's going to produce is a final data object markdown file, where that is going to be your PRP, right? Where that is the argument that is ultimately taken into this execute PRP command, where you're saying, hey, I have this final product requirements prompt file prepped for you. Now let's actually do the work and let's create the object. Let's build it in the development schema and let's follow all of the requirements here. And so again, here is the PRP prompt that is for the command, that is the / command, and then it goes through this large execution process. And I'm going to double check this all really quick before running it in our examples to make sure that this is generalized to everyone. And then at that point, you may require some iteration both within the phase 2 and phase 3 steps. But say you have a little bit of back and forth, or you one-shot it and you successfully get a object that once you're reviewing it and once there's the SQL output as well as the quality checks that Claude or whatever AI system you're using has produced, then you can promote to production. And I always recommend this step being human executed, and you can have AI produce all the materials you need. So all you need to do is just click a button, run a query, and then boom, it's in production. But this I always like to have the human control over, as opposed to having AI promote actual sources of truth to production without me looking at it. Now, having explained all of the different concepts in this PRP process for creating and altering data objects, let's actually get into some fun stuff and do some examples. So I have 2 examples I'm going to run through, this simple example and a little bit more of a complex multi-grain example. And for this simple data, and also for the more complicated data, we're going to be using this sample data set from Snowflake. I'll attach the information for this in the description of the video, or link it, better said. And what we're going to be doing here is we're creating a customer order summary object, right? So imagine you need to create a Tableau dashboard or Power BI dashboard, and you want to pre-aggregate your data or pre-arrange your data so that it is within a single object for you to connect to that is easy, and it is within a reporting view. So this request type is a create new single object. Here's what we're going to call it. It's a view. And then we're going to put it into this analytics development schema. So I have this analytics development schema created here. And then here we can see all of the data from the TPCH 100 data set. And what we're going to do is we're going to have 1 row per customer, historical orders, no date filter, key dimensions, and then here's the business context. So I'm not going to go through this in super detail, but notice that I've listed out the target sources, expected relationship, the join patterns, as well as the column values too, and requirements. And this is something, again, that I actually had AI help me complete. And I just reviewed it where I said, hey, exported data, here's what I want to do, and gave it a little bit more context. This, I've done it in both cases where I've individually filled it out and had AI helped it. It really just depends on how comfortable you are with your data. But given that this is just a demo, I felt pretty comfortable with having AI do this. Switching over here to my cursor interface, we can see I have the custom command for the generate-data-object-prp. So we're now stepping into phase 2 of our process. And then I have the file path for the INITIAL.md for the simple example here. And then what I'm going to do is I'm going to click enter, and I'm in bypass permissions mode, right? Because I just want it to start doing its research and start creating the file without having to ask me for any specific permissions. And so now it's going to go about investigating the snowflake, describing the table, doing the research, and ultimately creating the PRP. So this process, I find it depends upon the complexity of what you're asking Claude Code to do here, but it can take a few minutes, and typically it does take a few minutes for it to complete. So with that, I will pause and we'll come back here in a second once this completes. We haven't quite finished yet, but similar to plan mode with PRP generation, Claude Code actually asks some really smart questions to make sure that it's getting your data PRP right. And I'll just go through and answer these. So we only want customers with order. We will do the net of discount only. And then, yes, we'll include account balance. And so we'll submit those answers. And now it's going to go about continuing to construct this PRP. So that should be the last pause before we actually get to the PRP now. And now after a few minutes, the PRP has been generated successfully. We can see the file location. I have the preview pulled up here. It gives you a summary of the confidence, the different object, as well as the key design decisions and the contents that it is expected to create. And if I go here and go through the table of contents, it shows me all the different sections of the PRP. Now, I'm not going to go through these in detail as it would be pretty time consuming and not necessary, but the PRP again is in the repository I'm providing in the links in the description for this video. And actually, I did do a couple iterations after this where I asked it to create an analytics production schema that I previously didn't have created within my sample Snowflake instance here. And so now the score is 10 out of 10. But you can go through and see all of these different sections on your own within the repository. So now let's actually execute the PRP. To execute the PRP, we type in the prp-data-object-execute, and it is very, very similar to the generation step, where the next thing we do is we put in the file path that we want it to execute upon, and then we click enter. And so what this is going to do now is it's going to read through that PRP. And again, I'm doing it in the same chat just so it has that additional context. But if you're running out of context, this process should allow you to clear out the context from your Claude code and be able to execute this with minimal issue moving forward. And so now I will let this run, let it actually create the object in the development schema, give me the script to promote it to production. I'll review it, and then we'll come back here shortly once that's done. And a few minutes later, we have our final object created, our final development object with the script to promote to production ready. We can see within our final deliverables, we have the view, we have the production promotion, source materials, as well as a QC validation and the README, which I'm currently in, that tells us about this object. And it has also created a ticket for it. I had to do a little bit of iteration just to make sure all the folders were arranged properly, and I've made the changes on the commands moving forward, so you shouldn't run into any of these issues if you were to download and utilize these commands from this repository. But let's go into our web interface here to check out our Jira. We can see the ticket that's been created with the description to track this work appropriately within our instance. And then here we have our view, our development view, and I can see exactly what's been created with the DDL here. And we can see that it's bringing in total orders, total revenue by customer from customer orders, giving us the data here in different common table expressions, and then arranging it all within these joins. And I'm actually able to see the data with this data preview feature. And then going into our Snowflake instance here, I ran the QC query just to see what exactly would it return. And we have, I think, about 9 different QC queries here where I can click through and see the different results that are present, and everything seems to be passing. And that way, once I have that comfort that, hey, this looks good in development, then I can click, all right, deploy to production, go back to my ticket here and say, all right, move this ticket to done. And then it will move the ticket to done, and we've created a data object. It takes a little bit of work up front, but it really is fast, thorough, and it provides you all the different information and queries that you need to make sure you're creating a solid source of truth, right? And so this goes to the point that data issues or not having your data in a final state is, again, an opportunity and not an obstacle for us to utilize AI in this capacity. And then to wrap up this portion of the video for creating this simplified data object, I'm going to use our custom save work command that I covered in my last Claude Code overview video to save all the work to this branch, and then we will get started with the next object. Now, moving on to a more complex example, we have this multi-grain order analytics, and I'm actually creating a dynamic table, which is the equivalent to a materialized view in a lot of other data warehouse systems besides Snowflake. However, for this example, I just wanted to show a different type of a materialization that is allowed. And within Snowflake, dynamic tables refresh on a certain cadence specified by the user that creates them. But that said, without going too much into detail for what we're going to be doing for this dynamic table, essentially we're creating a data source using 7 different data sources here out of the 8 tables that are available within this sample schema. And it is using slightly different levels of aggregation. Again, don't really recommend this within tables, but I understand in different business situations, this might have to happen. I've certainly done this begrudgingly at times for different requests, but what we have is a line item level detail, but then there are some order level aggregations that go along with those specific line items. So this is meant to be a real use case that mimics actual real work within business here. And to follow what we did in the first part of the video, we will do generate-data-object-prp and then get the path here, copy and paste that, and then enter, and then we're off to the races. And please note that I've cleared my session so the Claude Code can start with a new set of context here. And for this example, I will pause here, let it run, and then we'll come back shortly to see how Claude handles this a little bit more complex example. And similar to the last example, we have a couple clarifying questions here that it has asked that are really good, where it says, hey, I noticed that it's just a 1 hour lag, but there is a dynamic table with window functions, which window functions are very expensive. Should we do a different lag? Bringing in different code labels here that might be more user-friendly, and then specifying the calculation for the customer percentage of regional revenue, and then bringing in additional columns, and then talking about, hey, what computing resources should we utilize for refreshing this table? And so I answered all of those questions here and clicked enter. And so now it will continue with the process too. And so this is just another example showing how Claude Code really is smart once you provide this template for building it out to make sure that all the details up front are accounted for as much as possible. It's not 100%, but it does it pretty well. And just like before, we have successfully created a PRP for the multi-grain order analytics dynamic table, which we can see is stored underneath this area for my 02 PRP example. And this gives a little bit of interesting insight into how Claude approaches it, where it gives you a confidence score, an 8 out of 10, and tells you all the different things that are included. And so rather than go through every single portion of this PRP, which I will do and review following this, I want to look at this confidence assessment in particular, because this can give you a really good snapshot of after the investigation, the comprehensive investigation that Claude Code did, what are the potential areas that are lacking here? And this is how, in the last PRP I did, I gave some iteration because of the specific area, because it said I didn't have an analytics production schema. So I created that schema for this video. But the one thing that's worrying me here is this summing percentages across all line items for customer will exceed 100% too. I'm not necessarily worried about the performance or warehouse side, given that this is static sample data. So what I'm going to prompt Claude here is, hey, how can we address this to have it not exceed 100%? And so this is a little bit into the iteration process of how you can review and work with the PRPs rather than, if you want to do a quicker review, looking at the confidence assessment is really helpful. But I still do recommend a little bit more of an in-depth review, just reading through, at least skimming this document. But that confidence assessment is a really good place to start. So we'll let this figure it out. And I'm going to read what it says here, and then we'll come back to you once I've given it feedback. So after it, basically, there's an aggregated value that is going to be repeated on all rows. So you can't sum it up because that would lead to greater than 100%, and it wouldn't make sense. But I just said, hey, keep it as is. It will document, and we just need to make sure that we require analyst awareness. There is probably a better way to solve this by one of the other approaches, but I just want to keep it consistent with my original requirements, and so I said keep it as is. And so now I am going to execute this PRP and have it run here. It should take a few minutes, and I will check back in once this more complicated PRP has been executed upon. And just one other thing while this is running, a potential great enhancement to some of these commands too might be to actually tell it to deploy specific agents to take on specific parts, right? For creating a Jira ticket dynamic table creation. We do have a Jira ticket transitioner agent as well as a command where we could potentially have it create a Jira ticket. So there's different areas where you could use subcommands or sub-agents that I don't have implemented currently within this that you could utilize to help improve some of these PRP commands. So just a enhancement idea for you all if you want to take it and run with it. But for now, I'm just going to keep with these prompts as I have them in this video. Okay, so this one took a little bit of time. And again, one or two more iterations as we ran into an unexpected difficulty here too, where I ultimately opted to have my PRP create a table and a stored procedure in a task instead of a dynamic table, which you can see it actually switched to the view mid-process, because if we look at the view here, it created it as a view instead of a dynamic table because the sample data has time travel limitations. So it's a time travel table, which I actually didn't know. So that's good to know that I can't use dynamic tables with time travel, but it altered to this view approach, which technically works, right? But when I was running these different QC queries, they took a very long time to finish. You can see it's about 6 minutes, 5 minutes, 3 minutes, and this was just too much time to wait for a production object, right? Ideally, when we're creating sources of truth and we're using this method, we're doing it in a way that is able to work quickly for business users and for data users like myself who want results returned quickly. So that is the reason I pivoted to having it create a table. I just essentially said, hey, I want you to create a table, task, and stored procedure, just as an option for this, for me to deploy it in the future. And so now we can see the production script is essentially using the same query that we were using for the view or for the dynamic table, but instead it's using to create a table. And then we have a procedure that will create or replace the table, and then an accompanying task that will run it on a certain level of frequency. And so all the data ultimately, after looking at the QC queries, looks good. It's for the view, so it runs a bit slower, but this is easily changed to the table, which I will do here shortly. All right, so I requested it to change from the view to the table. It did that. And then I ran the QC queries, and we can see everything here is taking seconds and sometimes milliseconds as opposed to minutes, which is much quicker. All of the tests are passing. The QC scripts look good. And I think that takes us to the end here for this second, more complicated example. Now I am going to save my work and then have it upload to my repository and then merge it into the main branch so that you all can see it and utilize this as needed. And that takes us to the end of today's video. Thank you so much for watching. Apologies, it was a little longer than I wanted, but I thought it was worth it to provide you both examples for something a little simpler that you can do with AI, as well as more complex, and figure out the challenges along the way that still might come with using this product requirement prompt for data creation and data object alteration. While there still is work involved, hopefully you can see now with this template that you really can advance yourself with AI, even if your data isn't in the place you want it to be, and utilize AI to get you to the place that you want to be with AI. So thank you so much. Please drop a like and subscribe, and I will see you for the next video covering data and AI. Bye now.